So to finish up on Chapter 8, we're going to take a look at garbage collection. So garbage collection is going to be the process of removing any unused or unneeded objects in memory. This helps to keep memory freed up for more objects later. So it's essentially just making sure that your program always has enough memory to spare for any objects that you create at a later point in time by essentially getting rid of anything that you don't really need anymore. So the question then is, how does your program determine which objects you don't actually need anymore? The way that this is going to work is that the Java Virtual Machine, or the JVM, will periodically run a garbage collector to remove any unreferenced objects from memory. So that's going to be the deciding factor, is if the object no longer has any references to it, then it's just going to go ahead and be garbage collected. So we have an example right here where we're going to say that we want to create a reference to some bank account object. And then at a later point in time, we're going to remove that reference. So we're going to say that instead of referencing this new bank account object with a balance of 500, we are instead going to have account 1 reference null. So what that means is that the reference that account 1 held to that bank account object, that's going to essentially be broken. It's going to now reference nothing at all. So then that bank account object that was previously being referenced, we would say that it is now unreferenced. And so at some point a little bit later on in our program, it's hard to say exactly when, but at some point it's going to be garbage collected. So essentially what that means is that the space is considered to be no longer in use, and so then later if you create another object that might go into that same location, it will just overwrite that content there. So of course I said that we don't necessarily know when that's going to occur. I should go ahead and elaborate on that. One thing to note is that classes can define a finalize method that Java executes just before objects of the class are garbage collected. That finalize method will accept no arguments and has a void return type, but it is difficult to predict exactly when garbage collection will occur. This is not a process that you generally have much control over. Instead, the program, in this case the JVM specifically, just kind of decides on its own whenever it is necessary to perform garbage collection, or to kind of do like a sweep across the memory of the program to determine if there are any unreferenced objects to go ahead and garbage collect. So for this reason, you cannot predict when the finalize method will be executed either, so it's not really considered to be a very safe method to use because you don't really know when it's going to be called upon. So if we want to go ahead and create something like that, we could go ahead and just create this finalize method. It's public void finalize. So as I mentioned, it has no return type. It accepts no arguments. So about the only thing that you might say that it's really good for could be a print statement, maybe for some kind of debugging purposes if for some reason you need to keep track of when things are being dereferenced or unreferenced. So if we want, we can go ahead and take a look at this. So we'll go ahead and minimize this. We'll come over here and we'll go ahead and create a new project. We'll make a new Java application, click next. So for this one, we'll go ahead and call this our GC demo. So GC just standing for garbage collection. We'll click finish. And so let's say that we go ahead and start by removing a couple of the comments, cleaning the style in this GC demo. And let's say right inside of here, we're going to be including some code to construct maybe a bank account object. So if we want to do that, we want to go ahead and create that bank account class as well. So let's go ahead and make that really quick. So this would be a little bit different from the bank account demo that we've seen in previous videos. For this particular one, we'll go ahead and just create this bank account. And the only things I really want to add to it are going to be a balance field so that we can go ahead and do something with the constructor, and then also include a finalize method. And then other than that, I'm not going to worry too much about the contents of this class. So I have a private double balance. So this is initially equal to 0. We'll go ahead and create a constructor that can take a balance. And we'll go ahead and say that we want this dot balance, the field, to be equal to the balance parameter. And then right here, we'll go ahead and include the finalize method. So we're going to go ahead and say public void finalize. And right here, let's go ahead and just put a print statement, and we'll say something like this item or this object has been garbage collected. Go ahead and save that. And it's going to give me a little bit of a warning right now, possibly for the override, so we're not going to worry too much about that. So right here, what we want to go ahead and do is create that bank account object. So let's go ahead and say bank account, say account 1 is equal to a new bank account object. And for this one, we'll go ahead and give it that initial balance of 500. And then at some point in time later, we're going to go ahead and garbage collect that. So we'll say account 1 is going to be equal to null. So that's how we'll handle the garbage or the unreferencing of this object here. So if I were to run this program right now, there is a possibility that it will finish executing before it really handles the garbage collection. So if that's the case, we might not even see that print statement. So if we run this, yeah, so there is the possible case of not getting to see that print statement because of that. So what I could go ahead and do to try to improve the, we'll say, reliability of garbage collection occurring is I can go ahead and include one more method call here. So we can actually make a direct request to the system to eventually perform garbage collection. But because of the fact that garbage collection still isn't easily predicted as far as the timing is concerned, this is just going to make a request to the system to eventually perform garbage collection. This does not tell it exactly when to perform that action. It's still going to be difficult to predict exactly when it occurs. It just increases the likelihood that it will occur soon. So because of all of that, in nearly all practical cases, you should never actually use this method. It's primarily just there for very particular kinds of demo runs for your applications. Once you actually deploy your application, you definitely shouldn't include something like this. But we'll go ahead and take a look at this, and we'll see if by making this call to the GC method from our system class, if that will actually improve it. So at this point now, we can actually see this object has been garbage collected. So as I mentioned, of course, the timing on this is difficult to predict. So to actually demonstrate this, I'm going to go ahead and include something else just after making that call to GC. I'm going to go ahead and do a few more print statements right here. For each one of these, let's say we go ahead and just do a test and then a number. Go ahead and copy that. We'll paste in about 5 of those, and we'll change this up. So we have test 1, 2, 3, 4, and 5. We'll go ahead and save that. And then if I go ahead and run this, so we can see that we've got our 5 different cases or tests right here, test 1, 2, 3, 4, and 5. And then right in the middle, we see that we've got this object has been garbage collected. So it kind of printed right in the middle of these different test cases, these different print statements that I included. And so if I were to run this again, then on this next one, we see that it goes ahead and shows it at the very end. So we can actually see that there's kind of a distinction depending on precisely when we run this program about where it's going to show that statement, this object has been garbage collected. And so that's related to this finalize method right here, which, as we've now seen, we can't predict exactly when that's going to occur. Of course, with the way that I've set this up, because of how simple this program happens to be, if I were to run this several times, you'll notice that in most of those cases, it's going to print at the very end. There's just going to be a few in this particular example where it's going to be a little bit different. But as the program becomes more complex and things like time sensitivity become a bigger concern, then of course this issue with garbage collection helps to show why it is that we can't really rely on that finalize method. Okay, so at this point, this is going to conclude everything for garbage collection and also wrap up everything for Chapter 8.